This is free response question number 6 on the AP Calc BC 2024 exam. I'm going to be working this out live. I have the scoring guidelines beside me, so I'm going to show how to present your answers, and I'm going to point out which parts are the important ones to get the points. Okay? Of course, this is all posted online, even the scoring guidelines, so you can refer to it yourself if you need to as well. I'm just going to interpret it I'm going to interpret it as I read it, okay? And it's actually pretty clear as to what gets points, what doesn't, okay? Number 6, this is the Maclaurin series one. This pretty much shows up in every exam, a power series, Maclaurin series type of problem. So you got to know how to do these. The Maclaurin series for a function f is given by this guy and converges to f of x for all x in the interval of convergence. It can be shown that the Maclaurin series of f has a radius of conversion of 6. Determine whether the Maclaurin series for f converges or diverges at x is equal to 6. Okay, so this center of the power series is 0. The radius of convergence is 6. So the interval of convergence is from -6 to 6. We don't know about the endpoints. X is equal to 6 is at the endpoint. So we got to check it manually. Okay, that's what this question's all about. So this is how I would show my work. Okay, I'm just going to do this live, and then I'll refer to scoring guidelines afterward. Okay, so at x is equal to 6, what is the series? We plug in x is equal to 6 there. It'll be summation as n goes from 1 to infinity, n plus 1 times x is equal to 6, right? So 6 to n over n squared times 6 to the n, okay? This simplifies to summation as n goes from 1 to infinity, n plus 1 over n squared. Does this converge? Does this diverge? Let's do a comparison test, or a limit comparison test. Let's say we compare with summation as n goes from 1 to infinity, 1 over n, the harmonic series. Which diverges. Okay? So we can do the limit comparison test. Limit as n goes to infinity, take the ratio of the two sequences or series, whatever you want to call it, n plus 1 over n squared, all over 1 over n, which equals to limit as n goes to infinity of n squared plus n over n squared, which equals to 1, okay? Therefore, by the limit comparison test, summation as n goes from 1 to infinity, n plus 1 over n squared diverges. Okay? So, what does the question ask, by the way? Determine whether the Maclaurin series for f converges or diverges at x equal to 6. So I would diverges. Okay? So let's see the scoring guidelines. Okay? So this would get me 1 point right there. Okay? And then this is, I guess this is 2 points, so then answer with reason. This would get me the second point right here. Limit comparison test diverges. And then doing all this. Scoring notes. To earn the first point using either the comparison or limit comparison test, and you must consider this guy, which I did, okay? So either you showed this, and then you can simplify to this. This is allowed as well, okay? And then I did the limit comparison just as I did in the scoring guidelines, and I said this is the harmonic series which diverges, and limit comparison test says that this is the limit of 1. So you don't have to say limit comparison test, but you need to show this and then say that it diverges. So I got to 2 points. Okay? That's an important part. All right, part B. It can be shown that f of minus 3, blah, 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 and that the first 3 terms of this series, sum to partial sum 3, is this guy. Show that this guy less than 1 over 50. Does this look familiar? This is the error. The actual value minus the partial sum. Okay, so what are the 2 error bounds that you learned in this class? It's the alternating series error bound and the Taylor's inequality. That's what I'm trying to the phrase I'm trying to look for. Okay, Of course, we will try to use the alternating series one because that one's easier if we can, and this is an alternating series, okay? So we probably need to write that, so let me turn the page, 6b, okay? So we can say summation as n goes from 1 to infinity, n plus 1 over, n squared minus half to the n is an alternating series. Okay? We probably need to at least say this, so let's write that. And then the alternating series, error bound. Okay? I don't know if you need to say this, but remember for alternating series, the maximum error is the first omitted term. Okay? So, f of minus 3 minus s of 3 is less than or equal to, the first omitted term is the fourth term, so n is equal to 4. Let's plug in n is equal to 4. So 4 plus 1 over 4 squared, and then we can just get rid of the absolute value. Or I guess we can do this, half to the fourth, okay? Which is less than or equal to, this is 5 over 16 times, that is 1 over 16, right? Which is less than or equal to 5 over 254. Did I do that in my head correctly? No, I did not. It should be 256, because it should at least end in a 6. I think that's correct, okay? So, this is what the alternating series error bound says. Okay, so we could even show that 1 over 50 is equal to 1 over, or 5 over 250. Okay? And this, 5 over 256, is less than 5 over 250. Okay, so this should be it. So we can even just say f of minus 3 minus s of 3 less than, what did it say? Less than 1 over 1. 1 over 50. I cannot speak right now in this video, okay? Let's see if I got all the points. So the idea is if we use the alternating series error bound, the maximum error, this is the error, is the first omitted term. Since we summed up 3 terms, the first omitted term is the fourth term, so we plug in n equals 4. Okay? Yeah, so I showed this. Use this fourth term, 1 point. Verification, this is the verification, another point. Okay? This is good enough, right there. Okay. C. Find the general term of the Maclaurin series of f prime, the derivative of f. Find the radius convergence of the Maclaurin series of f prime. This is very easy. We can differentiate and integrate power series. Remember that. Okay, so we just use the power rule here. F prime is equal to summation as n goes from 1 to infinity, n plus 1. We're differentiating with respect to x. This is the only term with x. Everything else is like a constant. So it becomes n x to the n minus 1 all over n squared times 6 to the n. Okay? This should be good enough. We can simplify. Whenever you simplify, you got to be careful because you can lose points. So let's be careful. Times x to the n minus 1 over n times 6 to the n. Okay? This should be simple enough to simplify without much error. Okay? Find the radius of convergence. Okay, so when you differentiate or integrate power series, the radius of convergence does not change. The interval of convergence could change, but the radius of convergence does not change. F has radius of convergence of 6. So F prime also has radius of convergence of 6. That's all you need to say probably. Okay, let's see the scoring guidelines. Yeah, we didn't have to simplify. This was good enough. This is fine as well. Okay. If you do simplify, it needs to be correct. So that's the risk that I was talking about. Okay. Radius of convergence. Second point is earned for a supported answer of 6. Yeah. So what is, because the radius convergence of the Maclaurin series of f is 6. The radius convergence of the Maclaurin series of f prime is also 6. Yeah, that's pretty much what I said there. So that gives me the point right there. Okay. Of course, you can do the ratio test and all that, but if you understand the simple concept, this is acceptable. Okay. And then 6D, g of x is this guy. Use the ratio test to determine the radius of convergence. Okay, this is just standard procedure. Let's do the ratio test. Okay, so limit n goes to infinity of a sub n plus 1 divided by a sub n. So it's n plus 1 x to the 2 parentheses n plus 1. Be careful, parentheses. N plus 1 quantity squared times 3 to the n plus 1 times the reciprocal. So it'll be n squared times 3 to the n over n plus 1 x to the 2n. Okay, that's the setup. That should give you a lot of points right there, or at least 1 point. However many points they give, okay? Now we gotta find the limit, have proper limit notation. This is important to get the points, okay? So let's start simplifying. It'll be n plus 2 times x to 2n plus 2 times n squared times 3 to the n. And then we have a n plus 1 cubed on the bottom. And then we have x to 2n, and then we have a 3 to the n plus 1 as well on the bottom, okay? So x to 2n plus 2 divided by x to 2n, that's just x squared. We can pull that out, okay? And then 3 to the n divided by 3 to the n plus 1, there's just 1 power 3 on the bottom. Pull that as well because it's a constant, does not depend on n. Okay, so this is just n plus 2 times n squared over n plus 1 cubed, okay? And then this, I don't know how much work we gotta show. The limit is 1 though, okay? So we set x squared over 3 to be less than 1, because remember the ratio test says this converges, or this guy converges only if the result of the ratio test is less than 1, okay? So we get that x squared is less than 3, okay? X squared is already positive when the absolute value is positive still, okay? So the radius convergence is, let's just say like this, okay? Or actually, let's keep it like this. How should I write it? Let's write it like this. There we go. Okay. Let's keep the absolute value. Okay? So the radius convergence is square root 3. Okay? Let's see the scoring guidelines now. Okay, so as I said, 1 point goes up to setting up this ratio up here. Okay? Limit is another point. And then radius convergence. So that's right there. Yep, showing the steps. Okay, the scoring guidelines has a little difference, and that's what this should be acceptable as well. Okay, it's just whether you absolute or you square it first or you absolute value first. The order doesn't matter, as I'll explain, because everything's already positive. Okay. Okay, so that's it for this question. Hopefully that was helpful to see how I wrote things out, and of course me explain the thought process, even though the scoring guidelines is pretty clear as to what they expect, but hopefully if that wasn't clear, I was able to clear some things up for you. All right. Again, there's lots of problems on Maclaurin series, power series in general, so you should know how to do these, and I'm going to be doing a series as to going over these types of problems. I'll have a playlist if you want specifically just on Maclaurin series, power series, and all that. Okay? For past free response questions. Please give this video a like if you found it helpful in any way, and hopefully I'll see you in another video as well. Bye.